That was just blind luck in a sense, right? Yellow fever virus and some of the things that we had done to understand that virus, we could just readily apply to hepatitis C. So I think if we hadn't had the freedom, to work on yellow fever, which, as I mentioned, there's a vaccine, so why are you interested in working on this virus that we can protect people against already? But, trying to understand some of the basic aspects of that put us in a good position to do something on hepatitis C.
Today, we are deeply honored to host Dr. Charles Rice, recipient of the 2020 Nobel Prize in Physiology or Medicine, whose groundbreaking work on hepatitis C virus has transformed global health and saved countless lives.
他最早是研究黄热病毒。黄热病毒研究得很有成果，所以后来大家就问他说，那你要不要跟我们合作来找出C型肝炎致病的机转，所以这是他最大的成就。
I grew up in Sacramento, California. As an undergraduate, I went to UC Davis, which has a really fantastic vet school. So I took a lot of different courses, but one of the ones that was the most influential was the introductory biology course. After college, I was kind of teetering between maybe being a winemaker or going to graduate school. I ended up convincing a couple friends of mine to sort of go on a year off in Central and South America. I think when I was in Peru, I got a telegram from my dad telling me that Caltech and UC San Diego had been accepted. I sort of had to get back to reality if I was going to do that. When I ended up arriving at Caltech, I was put in a virology lab. That chance encounter is, sort of why I started studying viruses and, sort of why I continued doing that. But I think that in terms of hepatitis C, sort of really not having any, sort of really compelling positive results, that this could be amplified in cells. With every one of these attempts, particularly in the chimpanzee model, we'd inject sort of the next hepatitis C construct that we hope would replicate. When hepatitis C replicates in the liver, it releases new virus into circulation, right, which can infect other liver cells and it can amplify. If you just inject an RNA into the liver and it just gets degraded, after a few days, it just sort of goes away. So if you take a serum sample from that animal, you don't see the RNA signal anymore. We inoculated with the RNA. One animal just received very large quantities of the RNA, and then for the other animal, we actually used a transfection reagent that's supposed to enhance the ability of RNA to be taken up by cells. So this time, the signal didn't disappear. It just sort of kept going up. In both of the animals became infected, and actually both of them became chronically infected. So I think that was, wow. I mean, I think early on we maybe didn't believe it. The next week we'd get the data and it was going up, not going down. So I think that was a pretty exciting moment. We were sort of confronted with hepatitis C with the treatment that people had shown worked sometimes for hepatitis B, interferon. And so people started using that on hepatitis C. It can work, but it had all these side effects. So you feel terrible, you have chills, a fever. In addition, people would not only, sort of be nauseous, but, they'd get depressed and just feel crappy. And right, so that's caused by interferon. And one of the experiences that I had was a family who had adopted a baby who was hepatitis C positive. And they were really trying to decide what to do, whether or not to sort of treat their young girl or, sort of wait for something better. They elected, sort of not to treat their daughter with the interferon therapy and kind of waited until some of these interferon-free treatments were made. And it really made, sort of a big difference for that family to have, sort of a safe, effective treatment without side effects for their child, who's now married with 3 children herself or something like that. And so, living through that kind of remotely with this family, it does kind of personalize, sort of what you're working on. And we kind of became friends. In the case of hepatitis C, the factors that I think prevented vaccine development were many. I mean, one is that people that resolve the infection naturally can be reinfected. There does seem to be some protection, but sort of it's not like many infections like yellow fever. If you get yellow fever and you survive, you're protected for life. And the other thing is just the incredible diversity of the virus. How do you elicit sort of a vaccine and immune response that would be capable of neutralizing or blocking the ability of all these different variants of hepatitis C to spread? People now have gone on to isolate, antibodies that are sort of broadly neutralizing. How do you actually prove that your vaccine works? And that's very, very difficult clinically. And then I think the other thing, if you can cure everybody in 2 to 3 months, and you're a vaccine development company wanting to make money, you kind of go, well, is there really going to be a market for my vaccine if everybody that gets infected can just be treated with these small molecules, right? So I think there's some economics to it. I think we need to have a better model and a way that is not necessarily determining the effort that's put into a vaccine by how much money it can make. Treatment, prevention, and also things that are economically viable or not, which I think is something in the infectious disease space that we feel acutely, in the sense that, there are lots of infectious diseases that don't affect, developed countries where progress needs to be made. These are just not solved yet. It's just a matter of finding the money to pay for the research. I think, part of the answer to that, sort of comes from, the government and the sort of organization of a country. But it is complicated in the sense there are so many steps from, sort of really sort of basic curiosity-driven research to recognizing that something that you're doing, has the potential to make a difference, and trying to sort of move that through further studies and preclinical development. And then how do you go from that to actually doing human studies and, actually showing that your idea sort of works? I would love to see more of a global effort to tackle some of these problems, because I think that's ultimately what's needed.
If we study or we design virus by AI, for example, would modern virology research do any harm to, in terms of ethics, to the human society?
I do worry, particularly seeing about some of the conflicts that are going on in the world right now, although I think we feel that the virologists are not smart enough to come up with a virus that is as well adapted to spreading in the human population as that one. Well, I think people do use AI to sort of ask questions. It seems to be becoming increasingly pervasive. There are a lot of, potential time-saving, sort of benefits of AI just in terms of practical things. I'm not opposed to it. I think you have to be your own worst skeptic. And, that's true more so now, perhaps, than it was in the past, because there's so much information and misinformation, sort of flying around. Maybe we need to strike up some collaborations with the folks here to, sort of move more into the AI space. I don't know, I'd be lost, I think. I might spend a little bit more time with the dogs, but I do think it's important that, given the limited resources that are available for science, when you become less productive as an older scientist. It's time to, throw in the towel and make room for the next generation. I think that humans, even as sort of very young humans, are very curious. They're capable of assimilating a lot of information and observing things and deciding for themselves what they believe and what they don't believe and why. So I think it's important to sort of have an educational structure that is open and, basically fosters, sort of curiosity and investigation. It's actually nice to come to an event like this where there are so many sort of enthusiastic sort of young people, and because, that's the future.